All right. And so our theme has been rational stuff, right? Okay. So when we said, shh, guys, hush. When I said what adding rational expressions and subtracting rational expressions, and then rational equations, and then rational inequalities, okay? Rational meant like fraction stuff, right? Okay, so what we're going to talk about today are called complex rational expressions. Jeremy, would you pass these out for me, please? All right. Now, this is what Jeremy's passing out to you. Okay. Now, we'll do the top part of this tomorrow. The radicals really doesn't fit into this, does it? Okay, we've been talking about rational stuff, so I want to keep the same theme. So I rearranged my plans, and we're going to go to these first. Okay. Now, so when we look at this word here, all right, complex rational expression. So we got the rational expression part. Now, what complex means, or a complex fraction is like a fraction within a fraction. I'm going to write this one down up here, but I've got it written over there on the board. Okay, that's an example of what a complex fraction is. Okay, thank you. It's a fraction within a fraction. Now, you get a lot of these in trigonometry. Okay, so get ready for them because trig is coming in January. All right, to a theater near you. Now, the way that you do the simple ones like this is you think of it as division. So you would think of this one as 1/2 divided by 3/4. And dividing fractions is easy as pie. You just flip the second and multiply. So that would be like saying 1/2 times 4/3. Okay, and again, you'll do a ton of these when we get to trig. All right, now, but when we get to these suckers over here, that really doesn't work out as well. Okay, so I'm going to show you a different strategy with these. Now, what I'm going to do here is work most of the odd ones, just like we've been doing, and you're going to do the even ones. All right, so let's look at 59 there. Now, it's kind of blurry, but you can see it on your sheet. Okay, now here's the strategy. Okay, what we're going to do is we're going to multiply the top and the bottom part by the least common denominator. Okay, now when we talk about the least common denominator, all right, understand something here. We're not really going to refer to x minus 3 as the denominator. Okay, now x minus 3 is the denominator of the whole thing, isn't it? Okay, but when I talk about the least common denominator, what I'm talking about is the denominator of each individual term. Okay, not the whole thing, just each individual term. So you see, like right here, what that denominator is obviously 3. And what do you notice about the other terms? What would their denominators be? They would all be 1s, right? Yeah, like understood 1s. And, you know, we really don't write that there. We just kind of understand it. Okay? Now, so let's do this. Now, here's the thing. We said these are complex rational expressions, right? They're not equations, so there's not two sides. So how can I legally multiply by the least common denominator? Because it's not an equation. Well, think about it. If I multiply the top, we're going to multiply the top by 3, right? By the way, the least common denominator is 3, right? But if I multiply the top by 3 and I multiply the bottom by 3, what am I really multiplying by? 1. Now, is it legal to multiply stuff by 1? Yeah, because multiplying by 1 really doesn't change anything. Okay? Now, so let's do this. We're going to multiply the top and the bottom by the least common denominator. So, you know, 3 is the only denominator there, isn't it? So the least common denominator's got to be 3. Now, when I multiply the top and the bottom by 3, I have to distribute the 3. Okay? So essentially what happens is you multiply every term by 3. Okay? Now, what's going to happen to especially the little bitty fraction in that? It's going to go away. Okay, and so that's the objective there of multiplying by the least common denominator is all the little fractions are going to go away. So that's just going to leave you with x, and then -1 times 3 would be -3. Okay, on the bottom, this is going to get me what here? 3x minus 9. Okay, now let's talk about, there's our answer, but now let's see if we can simplify it. All right, so can I like cancel out those x's? Can't do it because the operation's not multiplication, so right, subtraction. Okay, so the only way I could do it if the operation is multiplication, and we can make that happen by factoring, right? You notice the denominator is going to factor. Okay, so let's see what would happen. So factor out of 3 be 3 times x minus 3. And now can I cancel? Yeah, okay. Now, the answer there is not just 3, 1 over 3. Okay, all right, y'all follow those? Is that okay? That's it, okay. All right, let's look at 61. All right, so I'm going to let y'all tell me more about this one. So what do you think here's the common denominator? X, okay. So let's look. Now, do you see the subtraction in that? All right. Sarah, you asked about like subtracting stuff. What we always add the opposite. So I'm going to be very careful about doing that. Okay, so I don't make a mistake with a negative sign. Now, let's multiply by x. Now, here's what people do when they screw this problem up. They do this. See, I'm like psychic. I know what you're going to do. Okay, right. The reason why I have to do both of them is because you have to distribute. Okay, so just doing this is not going to work. I've got to multiply everything, every term by x. Okay, so now let's start up at the top. X times 1 would give me x, and now these x's are going to cancel. All right, x times 3 would be 3x. Okay, and those will cancel. So I'll just be left with 3x minus 1. Okay, now can I like cancel out some x's there in my answer? The operation's not multiplication. The only way I could do that would be to factor. And notice you really can't factor there, can you? Okay, so that's it. All right, is that okay? All right, let's move up. All right, so number 65. Let's do this one. Can y'all see that okay? It's from far away. It's like really blurry when you get close up. Now, let's look at this one. So what do you think here for the denominator, the common denominator? X plus 3. Now, some people might say x plus 3 times x plus 2. Now, did y'all really maybe think that x plus 3 times x plus 2 is the common denominator? All right, let's talk about this. Let me show you what would happen. All right, this is not the same problem. I just want to make a comparison, okay? All right, so obviously not the same thing, is it? Now, would the common denominator there be x plus 2 times x plus 3? Right, because what both of these are they're in the individual denominators. So this one right here is the denominator of the whole thing, but it's not like an individual denominator, right? Okay, just want to make sure that, you could really confuse that there. Bam, I like that. Now, all right, so the common denominator is just x plus 3. Now, what's something I probably should have mentioned I needed to do here? Right, plus a negative x. All right, now, so let's multiply by x plus 3 now. All right, so let's see, x plus 3 times x. That will give me x squared plus 3x. Okay, now my next one, those are just going to cancel. So it's going to leave me with negative x. Okay, now x plus 2 times x plus 3. How do we multiply that out? Foil it, right? Okay, so it would be x squared plus 3x plus 2x plus 6. And a lot of y'all, like you do the middle terms in your head. The 3x and the 2x would just give you 5x, right? So let's just do this. All right, question?
Why don't we multiply x plus 3 by the x and x plus 2? Because like in the past, almost we multiplied everything by the...
We are multiplying everything by the common denominator. All right. Now ask that again.
Why don't we multiply x plus 3 by x and then x plus 3 by 2?
I know what you're talking about. Okay, because this is a single term like that. Does that make sense now? Okay, I get what you're saying. So that is like a single term. Because what really happens with it, the fraction bar right there would group that together. And that's why it's a single term. Okay, I can see why we would ask that. Now, all right, we can clean this up in this numerator right there, right? That would be what? X squared plus 2x, okay, over x squared plus 5x plus 6. Okay. Now we're probably going to leave it like that, but yeah, go ahead. I'm putting it's 3x minus x. Combine your like terms. Okay. Now, again, well, we can't cancel out x squares. All right, I'm getting tired of asking y'all that anyway. I ask you, can you cancel that out? And you're like, no. All right, but how can I do it? Yeah, factor. So it'd be x times x plus 2. And really, all we're going to do is just go back to what this was originally. X plus 2 times x plus 3. So it was kind of a not a good thing to multiply it out, was it? Yeah, it was pointless. All right. So now those can cancel. So we get x over x plus 3. And I'm not going to ask you if you can cancel out those x's. I'm going to stop asking you that. Okay. All right. Let's look at this one. Okay. Now let's see if you can tell where this one's going to be a little bit different. It's not a lot. I'm going to go ahead and say plus a negative. All right. What's something there that you might think about when you would copy this one down? Yeah, right. See this part right here? You want to factor it, right? Okay. So let's just write over it. This would be x minus 2 times x plus 2. Okay. Now, so the common denominator is going to be x plus 2 times x minus 2. Here we go. X plus 2 times x minus 2. X plus 2 times x minus 2. X plus 2 times x minus 2. All right, let's go to cancel here. So those will go away. All right, now 3 times x plus 2. Give me what? X plus 6. Okay. All right, x plus 2's cancel out. So now you see why it was a really good idea to say plus a negative 4? Because otherwise, you wouldn't have thought to say negative 4 times x minus 2, would you? Not with that negative being right there. But if you do this, it's going to remind you to do that. That's why I make y'all do that. So negative 4 times x minus 2 would be negative 4x plus 8. All right, now on the bottom, just pretty much all goes away except for the 7. Okay, so now let's see, this will give me negative x plus 14. I'm just combining my like terms there. All right, can we say 14 over 7 can give me a 2 there? No. Okay, now, yes. So y'all said we couldn't say 14 over 7 was 2. That's right. So really, we're not going to be able to simplify this one. Now, let me say this. In college algebra, they don't let you leave it like this. Okay? Now, we've said, and I've said it like 3 times now, that you can't say that 14 over 7 is 2 because the operation is not multiplication. But you still can reduce this, and they would want you to do that in college algebra. Okay? So Ross, tell them how you would reduce that, college algebra student. You don't even know. Never mind. Okay. Nuh-uh. Miranda, how would you do it? Remember how I said, I would take this, but in college algebra, you had to go a separate step? Right. Okay. You would have to split it. And if you split it, then you can reduce it. Okay? So it'd be negative x over 7 plus 2. Okay? Now, for me, I think that right there is perfectly okay. I prefer that answer. But usually, when you get into college algebra, that's what they're going to expect. Okay? But for you guys, just we'll let that be okay. All right, let's do like one more here. All right, let's look at that last object. Now, here again, when you copy this down, you're probably going to copy it in a better form. What, x squared minus 2x minus 3? Tell me something there. Yeah, x minus 3 times x plus 1 instead right there. Okay. Right. The common denominator is going to be x minus 3 times x plus 1. All right, so x plus 1 cancels out the numerator. That gives me x minus 3 left over. All right, now all this goes away. So that's just 1. X minus 3 cancels, so 1 times x plus 1 would just be x plus 1. Yes, it's just going to end up being x plus 2 on the bottom. Okay, that's it. All right, and I'm not going to ask if you can cancel out those x's. Okay. All right, talk to me. We kind of get the idea now. So, and let's talk about this idea because, see, the thing is, this is sort of the 4th lesson in a row that we've all talked about rational something, okay? And you're going to have to keep them straight, all right? So let's go back. I made a big deal about when we add and subtract rational expressions that you couldn't multiply by the LCD because it wasn't an equation. Now, we can multiply by the LCD here because we're doing it on the top and the bottom. That means we're really multiplying by 1, and that's why it's legal. Okay? All right, questions? I did. Combine this one. Okay. All right, I'm done. Y'all can continue. I'm going to take a break.